There are a number of methods for factorisation, but the first thing I do is to check for common factors. Pulling out common factors can help simplify larger problems, and sometimes it's all you need to do. Let's try an example.
So in this example, we have factorise 18x cubed minus 3x squared. So we have these two parts that we're looking at, and we want to find common factors. So first of all, we have 18 and we have 3. What are the common factors for 18 and 3? Well, 3 can only be 3 times 1, so that makes it easy. If we have a 3 in 18, we can pull out the 3, otherwise we can't factorise the number because there's no point in pulling out a 1. 1 times anything is just whatever that thing is, and you can keep pulling out 1s forever. 1 times this times this. 1 times 1 times 1 times 1 times whatever will always just be that whatever, so... I'm rambling now. So for 18, we have 6 times 3, or we have 9 times 2, or we have, so we can also have 9 times 2, 18 times 1. So again, here we have the common factor of 3. So we can pull out a 3. Next we want to look at the x cubed and the x squared. So we have x cubed there and x squared there. So x cubed is just x times x times x, and x squared is just x times x. So the common factor here, we can pull out one x and another x, or we could actually pull out the whole thing, x squared and x squared, or our x times x. So if we pull out x squared from x squared, we're just left with 1, because this is like times 1. And if we pull out the x squared from our x cubed, we're left with our 1. So now that we've worked out what our common factors are, we can factorise. So we pull out the 3 first of all. So we're saying 18x cubed minus 3x squared equals 3. And we're pulling out that x squared, so x squared. And then we have our brackets, because they're saying, okay, what's left over after we pull out those common factors? For our 18, it was 6 times 3, so we're left with a 6. All that's left of our 18 is the 6, which is there. And what was left over when we pulled out the x squared from the x cubed was that x. So you've already actually done the work if you take the time to work out your common factors. Then we have our minus. The minus stays there unless you decide to pull out a negative, which we haven't done anything tricky like that. We're just pulling out a positive 3, so the negative stays as is. And then we have 3x squared. We pulled out a 3, so we're left with 1. We don't usually need to put 1, but we pulled out the x squared as well, so we're left again with 1. So 1 times 1 is just 1. So the reason you wouldn't necessarily put 1 times 1 is because that's kind of redundant. It's saying 1 times 1, you could say 1 times 1 times 1, it can go forever. It's just 1. And so this is our answer. 18x cubed minus 3x squared is equal to 3x squared times by 6x minus 1, all in those brackets there. The opposite of this might be, it says, okay, that's great. Now expand 3x squared, 6x minus 1. And these are very much linked, you'll see. So if we expand this, it's saying we want to multiply both of the components in our brackets by this outside part here. So we're doing 3x squared times 6x, 3x squared times negative 1 in a sense, but we just keep that negative there. We don't really need to worry about it too much because we don't have a negative anywhere else, so it just stays as is. So we have 18x cubed. If we say 3x squared times 6x, 3 times 6 is 18, x squared times x is x cubed, and then minus, because we have a positive 3 and a negative 1, so it's a negative, because they're basically, we're multiplying here. So we're multiplying 6x by 3x squared, and we're multiplying -1 by 3x squared in essence. So then we have minus 3x squared, because -1 times 3x squared is -3x squared. Again, another way of looking at it is you just keep that negative there, and you only look at the 1 and the 3x squared, and we say 3x squared just times that 1 is 3x squared, and there's a negative, so we just keep our negative. So there we go. That's factorization by a common factor.